Greetings, pre-calculus students, to another day in our unit on the unit circle and trig. So these past couple days, you have had the opportunity to get a little preview of the graphs of sine and cosine. You got a chance to sketch them to get a general idea of what they look like. Today we're going to discuss a couple key features that trig graphs have in common. A couple of key features, namely amplitude and period, as you can see in the objective in front of you. Amplitude and period, those are two key features that all trig graphs share. And then we're going to actually look at a few trig graphs and identify these key features just through the visual representations of these functions. So let's get to these two new vocab words. So first, amplitude. So the amplitude of a trig graph is equal to half the height of the curve. Okay, half the height of the curve. Now you'll see in this bullet point that I defined what the height actually represents. It represents the highest point minus the lowest point. So let's pretend your highest point is like 6 and your lowest point is 2. That means the height of your curve is 4. But that means your amplitude is 2 because it would be half the height of the curve. Okay, so that's what the amplitude of the curve will represent. The amplitude of the curve, half the height of the curve. So that's the first thing. So that one's pretty straightforward. That one, typically most students are going to have less trouble with than this next one. This next new concept that we're going to talk about, which is period. So the period of a trig graph can be a little bit tricky. Okay, but in terms of definition, first and foremost, it is the horizontal length. Okay, so horizontal. So you want to think of the x-axis. You want to look at the x-axis when you're determining the period. The horizontal length of one full cycle of the wave. Okay, one full cycle of the wave. Now the question is, well, what is one full cycle of a trig graph? Well, in the previous lesson, you learned this idea that trig graphs are what we call periodic. And they're called periodic because they just repeat the same pattern over and over. So a period, okay, hence the word periodic, a period is how long does it take the graph until it just repeats the same pattern, okay? So how much does it cover horizontally speaking? So how much of the x-axis does it cover before the same pattern just repeats again? Okay? So in other words, another way to think about this is how long until the same pattern repeats. And some of you got a pretty good indication of that once you graphed, for both sine and cosine, once you graphed the positive angle measures and the negative angle measures, you saw that both sides were basically the same. Okay, they were just repeats of each other. So that was your first introduction without formally being mentioned, this idea of what a period is. So let's look at these graphs, all right? Let's look at, I forgot that I wrote that there. All right, how long it takes before the graph repeats. Okay, so let's look at the sine graph first, okay? So for those that completed the Desmos activity from a couple days prior, you ended up with a graph basically of this shape, except you did two separate graphs of the positive side and the negative side in terms of the angle measures, but you ended up with this shape, okay? So you saw that the sine graph has this wave-like pattern to it where it just goes up and down, up and down, up and down, right? It just goes up, then down, then up, then down. Just keeps on repeating that pattern, so on and so forth. So let's first talk about the domain, okay? Let's talk about the domain. So if you forgot, remember, the domain is basically what x values, okay, or what input values, but in this case, x values. What x values does this graph consist of? Well, a trig graph actually continues on to the left and to the right indefinitely. You can put any x value into the sine of x function, and you will get a y value out of it. Okay, which hopefully makes sense, because if we think about just the unit circle, right, we can go past 360 degrees. We can go past 2 pi, right? It doesn't just stop there. We just keep on going around and around and around. And as a result of that, the domain of the sine graph is just negative infinity to infinity. Now let's talk about the range. Now, if you recall, the range is what y values does the graph consist of? Well, hopefully you noticed that the sine graph does not go up forever, and neither does it go down forever. It actually reaches a peak or a high point that it never goes above, right? And hopefully you saw that the sine graph never goes above y is equal to 1. Okay, it never goes above y is equal to 1. That's as high as it goes. All right? Which hopefully makes sense, because the unit circle, right? If we think of the unit circle never goes higher than 1. That's the whole reason why it's called a unit circle, because the radius is 1, but it never goes higher than 1. So hopefully it should make sense why the sine graph never goes higher than 1. And conversely, the lowest y value the sine graph, the basic sine graph ever touches is -1. Right? You can see here it never goes below -1. Okay, that's as low as it goes, which, once again, tying it back to the unit circle, hopefully makes sense, because the unit circle never goes below -1. That's the lowest point on your unit circle. It never goes lower than -1. So that means our range is going to be all values between -1 and 1, including. Okay, inclusive. So we include -1 and 1, that's why we put the square brackets, and then it's everything in between. That's a little bit of review. Okay, which actually goes to this idea of the max is going to be 1 and the minimum is going to be -1. Because once again, the max is just the highest y value. In this case, it's 1, and the minimum is just the lowest y value. In this case, -1. All right, let's talk about amplitude. Let me just quickly write that: highest y value, lowest y value. Okay, now let's talk about the amplitude, which was one of the new, one of the new concepts we just talked about. So remember, it is half the height. And remember, the height is the highest point minus the lowest point. Well, we just said that the highest point was 1, right? That's the max. We just said the highest point was 1. So let's quickly calculate what the height is. So the height is going to be the highest point 1 minus the lowest point, which was -1. So that gives us 2. So the height of the curve is 2. So the amplitude, remember, is half the height. So in this case, you would end up with 2 divided by 2. So the amplitude of the basic sine graph, so just sine of x, in other words, so f of x is equal to sine of x, is just 1. Okay, it's just 1. Now let's talk about the period. So this is where it can get a little bit tricky. So the question is, how long does this graph take? All right, how long does this graph take x-wise, so horizontally wise? So you want to make sure you're looking at the x-axis. How long does this graph take to repeat the exact same pattern over and over? Well, the easiest way to do this is to pick a starting point. Okay, typically I like to start at where it crosses the y-axis, or the y-intercept. So let's just choose this point. Okay, so it crosses the y, at least this graph crosses the y-axis at the origin, at 0. Okay, so now let's follow. Let me use actually a different color because this is already yellow. Let's follow this graph. Okay, let's follow this graph. All right, so it goes up. So remember, we started at the origin. All right, so it goes up, reaches a maximum, goes down, reaches a minimum, then comes back up. Okay, so that right there, what I just highlighted, that would be one cycle. Okay, that would be one cycle for this graph. Why? Because think about what happens after that point. Well, after that point, this graph is just going to repeat the exact same pattern. It's just going to repeat. It's going to go back up, then going to come back down, then come back up again. Okay? So that part highlighted in green would be one cycle. But remember, for the period, we are looking at the x-axis. How long does it take horizontally? How long does it take horizontally speaking? Well, if we start here at 0, remember we're looking at the y. If we start here at 0 and we ended at 2 pi. Okay, so we started at 0 and we ended at 2 pi. So that means the period is 2 pi, because that is how long it took to complete one cycle, or one full pattern, quote unquote, if you want to call it that, before it just repeated the exact same thing again. And then finally, let's talk about the y-intercept. So the y-intercept, conversely, is something that we already mentioned. It's just where it crosses the y-axis. So where does the graph cross the y-axis? The graph crosses the y-axis at 0. And those are your features for the sine graph. Those are your features for the sine graph. All right. Now on the next slide, we have the cosine graph. On the next slide, we have the cosine graph. Now for this one, I actually want you to try this one out on your own, okay? Because it's not going to be much different. I mean, I'll be honest here. One thing that I will tell you is that just like the sine graph, the cosine graph does continue on forever. It does continue on forever. So once again, I want you to do this one on your own. So fill out each of these different features. So domain, range, amplitude, period, maximum, or max, min, and y-intercept. Okay, so that one I want you to do on your own. But hopefully, I'll be honest, it's not going to be much different than this one. So hopefully, as long as you understand why each of the answers are what they are, you'll be fine. So now let's look at a few, different types of sine and cosine graphs, because not all our sine and cosine graphs are just going to be as simple as, the ones that you graphed with the Desmos tasks, all right? So let's look at this one, okay? Let's look at this one. So identify the given features of each of the graphs. All right. So let's see. So we have a graph here. Could be sine, could be cosine. Don't really know. We haven't really gotten to the point where we've discussed how to determine it, but we're asked to determine each of these features. So let's do the range first. Remember, the range is the y values. So how low does the graph go? How high does the graph go? Okay, so how low does the graph go? How high does the graph go? Well, let's see. The graph looks as though it goes as low as -3, right? It looks like it goes as low as -3, and then it goes as high as 3, okay? Goes as low as -3 and as high as +3. Okay, so that means the range is -3 to 3, including those values. So that's why we put the brackets there. Okay, so that's the range. So now the amplitude, remember, is half the height. Half the height. Well, the highest point is 3. The lowest point is -3. So I'm just going to calculate the height here off to the side. So the highest point is, mess that up. The highest point is 3. The lowest point is -3. And we find the difference between those two. So it looks like the height is 6. Okay? And remember, the amplitude is half the height. So the height divided by 2. So that means the amplitude is 6 divided by 2, which in this case is just 3. Hopefully pretty simple enough. So now let's talk about the period. Okay, now let's talk about the period. Well, remember, the period is how long does it take for this graph to repeat, or to complete a cycle, or repeat a pattern, in other words. Well, let's see. If we start at the y-intercept, so let's start with this graph. So it goes up, and then it comes down, okay? So we're not done yet. That wouldn't be one full cycle just yet, because it has to go down first, then come back up, and then it repeats, right? Then it repeats. Okay? So the part highlighted in yellow, that would be one cycle, one full cycle. And then the part highlighted in green would be another full cycle. And then it would just keep on going and going and going, up and down, up and down, up and down. But the question is, remember, the question is how long does it take horizontally speaking? So pay attention to the x-axis. How much of the x-axis did it cover to complete one cycle? Well, let's see. If we started here and ended here, well, how much is that? How much is that? If we start at 0 and you end at, and I know this looks confusing, this pi is supposed to be for that. Okay, so it's supposed to be for that mark right there. Since the graph ends at 2 pi, that means the halfway point would be 1 pi. So it looks like it takes 1 pi, right? If you start at 0 and then you end at pi, that means you've covered 1 pi. You've covered 1 pi. So that means our period is pi, or 1 pi, because that's how long it takes, horizontally speaking, that's how long it takes to complete one cycle. And then the max and min, we kind of already talked about it. The highest y value is 3, and the lowest y value, or the lowest value, is negative 3, right? That's how we got our range to begin with, right? That's the max is how high does it go, and the minimum is how low does it go. All right. So now let's do another example. Let's do one more example. Okay, here's another graph. Looks a little bit different. Looks like a cosine graph. Could be a cosine graph. Looks like a cosine graph. So now let's do the range. Let's do the range. Well, let's see. What is the lowest y value? Looks like it's negative 4. What is the highest y value? Looks like it's positive 4. So the range would be negative 4 to positive 4. Amplitude, once again, amplitude is half the height, right? Half the height. So the amplitude is going to be the height divided by 2. So in this case, let's see. It's going to be 4 minus negative 4, right? Because to find the height, you do the highest point minus the lowest point. So 4 minus negative 4 divided by 2. So 4 minus negative 4 is the same thing as 4 plus 4. So it looks like we end up with 8 divided by 2, giving us 4. So our amplitude is 4. Remember, the height divided by 2. Height divided by 2. Now the period. All right, let's see. Let's see if we can figure out the period. Well, once again, let's start where it crosses the y-axis. All right, let's start where it crosses the y-axis, which would be here, right? All right. Let's see if we can determine what the period is. Well, let's see. So the graph goes down, then comes back up. That looks like one cycle to me, because if I were to continue, it would just do the exact same thing. It would just do the exact same pattern. Okay, as you can see, the parts highlighted are exactly the same shape and share exactly the same behavior. They go up, they go down, reach a low point, come back up, right? So the part highlighted in blue and green, each of those would represent one cycle separately. But once again, we're looking for how long does it take horizontally speaking. So if we started at the y-axis and ended, it looks like we ended here, right? That's where we ended. So it looks like if we're looking at the x-axis, it took us 2 pi. It took us 2 pi to complete one cycle. So that means our period is indeed 2 pi. Okay. And then we already talked about the max. The highest value of this graph is 4, and the lowest, let me use a different color. The lowest value of this graph is negative 4, respectively. All right. Now the next two problems you will be doing on your own. Okay, so the next two problems you will be doing on your own. So this graph, and I tried to, whatchamacallit? I tried to help you out a little bit with the coordinate grid, so I made sure to specify on here that this dash right here is pi, and then this dash right here is negative pi, just in case to help you out a little bit. And then this dash right here would represent 3 pi in the x-axis, and then 4 pi after that. So that's one on your own problem, and then the next slide would also be an on your own problem. Okay, so for both these graphs, you're going to do the exact same thing that we did in the previous 2 slides. Identify the range, amplitude, period, maximum, and minimum. Okay, so you got these 2 on your own problems and identifying the features of the basic cosine graph as well. Okay, so that is it for today's lesson. Not a very long lesson, to be honest. But we did learn a couple of new concepts in relation to these trig graphs, namely amplitude and period. But other than that, that's basically it. Hopefully the lesson went well. If any questions do pop up, as usual, let me know. Feel free, reach out to me, leave me a comment in the classroom, do what you need to do. Otherwise, I hope you all stay safe, and I hope you enjoy the rest of your days. See you later.